So I drop 4 Parquet files to complete.txt. Let's just enter. Let's see what happened. So you see left side C. Boom. So already copied to GCP and log is there. In the last video we got files moving from our on-prem Windows server to GCS using storage transfer service. It worked, but look at this setup. See the transfer agent. It runs on a schedule every n hours. So if our pipeline finish at 2:47 a.m. and drops the files, they just sit there until the next schedule run. That's dead time in our pipeline. That is not data engineering, that's hoping. Today we fix it properly. See, our Docker container is running and also our agent pool right now connected to the running container. Now watch this. I'll drop some Parquet files into the source folder and nothing happens. Container is running, our agent pool also connected and nothing happened to the bucket. No file uploaded. So the file won't upload until the next schedule window. This is a problem. Our data pipeline needs to react the moment files arrive, not an hour later. So how do we make this event driven? 3 options. Let's look at all of them. So first option you will find in a lot of tutorials. A local script called a cloud function. The cloud function called GCS. But look at the architecture. You are adding 2 network hops just to wrap a storage right. You are paying for cloud function invocation and you are deploying serverless infrastructure to solve a problem that doesn't need it. It's over engineered. Option 2. A shell script using gsutil directly. Drop a trigger file, script detects it, runs gsutil cp command. This actually works. It is simple, but it is a PowerShell or bash script, harder to read, harder to extend, and gsutil hides what really happening under the hood. Not ideal for a data engineering. And finally, option 3 is pure Python. The Watchdog library uses OS level file system events, not pooling, not a timer. The operating system itself tells our script the moment a file appears, so zero delay. And we use official GCS Python SDK directly, so we can see exactly what is happening and proper logging and extend it later. This is the one we are building. Here is what we are building. On left side our Windows machine, we drop files into the source folder and that is mounted inside the Docker container app source. So no copying, no syncing, it is the same folder both sides. Inside the container, Watchdog is watching. The moment complete.txt file arrives into the source folder, it fires. Watcher.py picks up every other file, loops through them, uploads each one to GCS over HTTPS using our service account key, which is also mounted as a read-only volume. Logs also written back to the log folder, upload_log.txt file. So we can open the file in a notepad anytime without touching Docker. One container, 3 volume mounts, 0 scheduler. So finally how that works, files arrive in our source folder and Watchdog start observing complete.txt file. As soon as complete.txt file arrives, watcher.py start uploading them using JSON key file authentication to GCS bucket and writes the log, upload log files here. And finally archive all the source files into an archive folder. So our job is ready for next batch. So let's go inside the demo and see how that works. So here is our main Python file. The whole solution is one Python file. We are using 2 main libraries, Watchdog and Google Cloud official library. Next, we are using 4 main parameters, bucket name and the subfolder or the prefix name under the bucket. And then the source folder mounted to app source and the trigger file. We are calling it complete.txt. Next block, we are just logging into the on-prem upload.log.txt file and we mounted that folder to app log path. We created upload files function. So that's the main function that actually upload all the files to GCP bucket as soon as trigger file arrived, except the trigger file. Log the file uploading process, and finally set if everything is okay or anything failed. Once the specific file upload done, it will try to create an archive folder based on today's date and then move the file into that folder. We'll see into the demo. The WatchHandler class, that is watchdog call. Every time a file created, one check at the top. If the file is not trigger file, then it will skip. Otherwise, it will go inside, that is trigger file detected, and call the upload file function. Also, I have included some other events like when the file created, if the trigger file modified, for example, we copy the complete.txt inside the folder and then just rename it to something else, or we copy one text file and rename it to the complete.txt file, then also it will work. And finally, here is the main section from where we actually start the program. In the requirement files, we are using Watchdog version 4 and Google Cloud Storage version 2.17. And here is the simple Docker file. We're using Python 3.11 Slim, and we configured app is our working directory and copy everything to the app folder and start installing our required libraries. Then copy our watcher.py file into app directory and also create two folders, one for source, another for log under same app folder. And here we are setting up four environment variables: source folder, bucket name, and the bucket subfolder. And finally, once that is done, we are just running watcher.py. So first, let's build our Docker image. Open a terminal, and here is the command docker build tag. So we are naming it GCS watcher and build the image under the current directory. Hit enter. So we started building the Docker image, and on the left side we can see the image already built here, but it is not running yet. And click containers. We can see only our transfer agent is running, but not the new watcher agent. So here is the command to run the Docker image. So we are running this background mode. So we are setting up environment variable bucket name. So that is our bucket name, upload on-prem files, that already set up GCP, and under on-prem files we have a landing subfolder. Here in GCP console we can see our upload on-prem files. Under that we have a subfolder called landing, and right now it is empty, no file inside that. And next we are mounting our source folder and log folder to the container directories. So here is our on-prem folder. So under data to transfer, so we have two folders, source and logs. So inside source we have archive folder, but we need to drop files here. Once upload to GCP done, then the watcher script will move them into archive folder. So right now it is empty. And also we have log folder, so the log will be available under this folder. And next we have service account key file, and we are mounting that into the app secret folder inside the container. So let's run, and we can see our GCS watcher started. And if we go to container, so we can see now GCS watcher started watching. So let's go inside the container, and we can see live log. So it's saying GCS watcher is running. Now, right now it is watching under app source folder, and the target bucket will be this one. And that is saying trigger is drop complete.txt file to upload. So let's drop some files and see what happens. So I dropped 4 Parquet files, but nothing happened here because the watcher keep watching for complete.txt file. That means once our source files are ready, the source job should create this complete.txt file so that the watcher knows these files are ready to be uploaded to the GCP bucket. So let's create the watch trigger file now, and let's see what happens. To complete.txt, let's just enter. Let's see what happened. So you see left side, see, it's boom. So already copied to GCP and log is there, and all files disappeared from the source folder and one archive folder also created, and all these files moved here. And let's verify what happens in the GCS bucket. So here inside GCS bucket, let's refresh. We can see all the files are sitting in the bucket under landing folder. Wow, that's amazing. It's a zero delay. As soon as files are arrived, it will auto upload into GCS bucket. Also, let's verify our log file. Inside log, we can see one log file created. Let's open the file and we can see the log is available. What file uploaded, when uploaded, and where that file archived after the upload done. Three simple files and just a Docker command. That's all we need to automate this one to upload data in real time and also trigger based. Code will be available in GitHub and I'll add the link below. We will explore more in my next video. If you found this helpful, please like and subscribe. Thanks for watching.